for intermediate algebra, chapter 7, section 5, rationalizing a denominator. It also concerns itself with what we call a conjugate. Keep in mind, a conjugate is really just the second part to a difference of squares. Alright, rationalizing a denominator. We can never have a square root in the denominator's place. We can have perfect square roots because they become real numbers, but numbers that aren't perfect squares are irrational. We can't have an irrational number in the denominator's place. So what we do is we rationalize it. The way we rationalize it is that if we take square root of 5, we know if we multiply by square root of 5 again, this will be 5 times 5, which will give us square root of 25, which will give us 5 on the bottom. That gives us a real number on the bottom, which helps us. The only problem is when we change a fraction, if we multiply the bottom by something, we have to do the top, the numerator, by the same thing. So the top becomes 2 square root of 5 over square root of 25, which the final answer is 2 square root of 5 over 5. We come over and look at this problem. We have to simplify these fractional radicals first. So in this particular problem here, we have square root of 16, which is 4. 4 times 2 gives me 8 in the numerator's place. On the bottom, I can take the square root of 9 and bring the 3 outside, so I now have 3 square root of x. So the only thing that's a problem with this in the denominator's place is the square root of x. So what I do is multiply top and bottom by square root of x. This gives me 8 square root of x over 3 square root of x squared, which square root of x squared is x. So it now gives me 8 square root of x over 3x. Notice in both problems, I have no radical in the denominator's place. It's okay to have the radical in the numerator's place, but not in the denominator's place. If I come over here and look at this, in this particular problem, the denominator has 2 radicals, okay, being subtracted, the difference of 2 radicals. I can have the sum of 2 radicals as well. Well, all we do is we multiply what's called the conjugate. And all the conjugate is the same first term, same last term, opposite sign. The problem here is we've got to multiply top and bottom by this, just like we did over here. Whenever we multiply the denominator by, we've got to multiply the numerator by the same thing. So what happens is we go square root of 6 times square root of 5, which is square root of 30. Square root of 6 times square root of 3, which gives us square root of 18. 2 times square root of 5, which gives us 2 square root of 5. 2 times square root of 3, which gives us 2 square root of 3 on top. Now, the bottom, because it's a difference of squares, I don't have to worry about the middle. So what I'm going to do is go square root of 5 times square root of 5, gives me square root of 25, minus, because it's a minus times a plus, square root of 3 times square root of 3, which gives me square root of 9. Square root of 5 is 5, square root of 9 is 3, 5 minus 3 is 2, so it gives me 2 on the bottom. Now, the only thing I have to do with the top is I can't combine anything because they're not like terms. But the square root of 18 here can be simplified. 9, which is a perfect square, divides into the square root of 18. So 9 times 2 is 18. Square root of 9 is 3. That's how I get the 3 square root of 2.